Hi, this is Manoj Yadav and you are watching Mechanotherapy. So guys, in our previous lecture we discussed about the various types of loads and various types of supports. Now in this chapter we will discuss the various types of beams. As we have already discussed that what a beam is. Beam is a structural member which is used in building work and which is supported at some points and which bears the load. So the ultimate use of beam is to bear the load. Now there are total 7 types of beams. First one is simply supported beam, cantilever beam, fixed beam, continuous beam, overhanging beam, determinate beam and indeterminate beam. So there are total 7 types of beams. Now in this lecture we will discuss all the types of beams one by one. So let's take the first beam, simply supported beam. A beam which is supported at the end points, that is known as simply supported beam. Now let's see the diagram. This is the beam. The supports are here at the end points. Supports may be different. One is simple support, one is roller support, and one may be hinge support or one simple support. So this type of beam in which the supports are at the end points of the beam, that beam is known as simply supported beam. Now the second one is cantilever beam. The beam which is free at one end and fixed at the other end. You can see we have fixed this end of the beam, and at the other end there is no support, though no reaction will be there. So this type of beam which is fixed at the one end and free at the other end, this type of beam is called cantilever beam. So whenever you will draw the free body diagram of this beam, we will take one vertical reaction, one horizontal reaction and one movement at this end only, and there will be no reaction at this end because here we are having the free end, no support is there. Now the third one is fixed beam. You can see if we fix both ends of the beam, here I have fixed both ends of the beam, this end is fixed and this end is also fixed. So this type of beam is called fixed beam. So whenever you will draw the free body diagram of this beam, you will take one vertical reaction, one horizontal reaction and one movement at this end. Similarly, one vertical reaction, one horizontal reaction and one movement at this end. Now the next one is continuous beam. A continuous beam is a type of beam which is having more than 2 supports. Suppose a beam is supported at 5 or 6 points, then this type of beam is known as continuous beam. You must have seen this type of beams in the various bridges which are made across the river. So a number of pairs are given to support the beam. So that is a simple example of continuous beam. A beam which is having more than 2 supports, that is known as continuous beam. Now the next one is overhanging beam. Overhanging beam is a type of beam in which some length of beam hangs beyond the support. Suppose these are the 2 supports, this is the beam. Now you can see that this length of the beam is hanging beyond this support. So this type of beam is known as overhanging beam. Now overhanging beams may be of 2 types. One is single sided overhanging, or it may be both sided overhanging. You can see in this diagram, this is the both sides overhanging beam. So the beam in which some length of the beam extrudes beyond the supports, that is known as overhanging beam. So these are the main 5 types of beams. Now we have 2 more types of beams. One is determinate beam and another one is indeterminate beam. Now see what is determinate beam. A beam in which we can calculate the value of reactions by using the equilibrium equations, that beam is known as determinate beam. Now you know the equilibrium equations are sigma fx equal to 0, sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0. That is, for equilibrium sum of all horizontal forces must be 0, for equilibrium sum of all vertical forces must be 0, and for equilibrium sum of all movements must be equal to 0. So if by using these conditions of equilibrium we are able to find out the various support reactions, then that type of beam is known as determinate beam. So a simply supported beam, a overhanging beam, and a cantilever beam, all these types of beams are determinate beams. Why? Because one unknown is here and one unknown is acting here. So only two unknowns are there, and we are having the three reactions to solve the equations. So we can easily find out the reactions. Similarly, in case of overhanging. Now, in case of cantilever, we have one vertical reaction, one horizontal reaction, and one movement. So three unknowns are there, and we have the three conditions of equilibrium. So we can easily find out the value of reactions as well as movement. So these types of beams are known as determinate beams. Now the last one is indeterminate beams. The beams in which we can not find out the value of unknown reactions by using these three conditions of equilibrium are known as indeterminate beams. For example, the fixed beam is the example of indeterminate beam. Why? Because when we draw free body diagram of this fixed beam, we will have to take one vertical reaction, one horizontal reaction, and one movement at this end. Similarly, one vertical reaction, one horizontal reaction, and one movement at this end. So you can see total 6 unknowns are there. Now you have only 3 equations to solve these unknowns, and we have 6 unknowns. So this is not possible to find out the value of reactions or unknowns in this case. That's why this type of beam is known as indeterminate beam. Similarly, another example of indeterminate beam is a continuous beam. You can see when we will draw the free body diagram of this continuous beam, we will have 1, 2, 3, 4, total 4 reactions, but the equations are only 3. Unknowns are 4 and equations are 3. So we will not able to find out the value of reactions in case of continuous beam also. So this continuous beam is also a type of indeterminate beam. So guys, this is all about the various types of beams. I hope that you must have learned everything about the types of beams. So in our next lecture, we will discuss how to determine the value of reactions in these types of beams. Till then, thank you everyone.